Welcome. This session is going to be on basic statistical concepts and descriptive statistics. We are going to be looking at levels of measurement, reliability, and validity. We're going to be looking at descriptive statistics. We're going to be looking at measures of central tendency and then actual concepts of reliability and concepts of inferential statistics. All right, measurement. In statistics, the level of measurement of a variable is a classification intended to describe the nature of information contained within numbers assigned to objects and therefore within the variable. Now, during this session, we're going to be talking about quantitative research. So the measurements will actually have numerical values. There are 4 levels of measurement, and this is important for you to remember. Nominal, ordinal, interval, and ratio. Nominal are categorical variables. And the best way to remember nominal variables is by examples. In fact, the best way to remember all of these 4 areas are by their examples. So nominal is categorical, not used a lot in different types of statistics, but again, you can use it along with other variables. So some examples would be gender, male, female. It's nominal, it's categories. Marital status or religion preference. And you can actually include these in numerical because you can assign numbers to the different categories. Ordinal is rank order data. This is like the top ratings for music, any kind of rank order. You can use this in some appropriate statistics, the median, interquartile range, any of those type things. But remember, ordinal is rank order data. Interval begins to get more usable in statistics. You can use it in the mean, standard deviation, correlation, regression. You can use it in a lot of different types of analysis. Interval is things like temperature, IQ, personality assessments, curved grades. Those are really good examples. And one thing you need to remember about ordinal is there is no true zero. No true zero in interval. And temperature, you can have less than zero. It can be below zero. So there's no true zero. And you may see that on an NCE question. The last one is a ratio, the most advanced measurement. You can use it with all possible statistics. And the thing you need to know about ratio, remember ratio, O ends in O, that it does have a true zero. Age, weight, annual income. You certainly can't be less than no age. You could not weigh less than 0. You hope your annual income is not less than 0. Money in my pocket, a lot of times I have less than 0, but ratio has no true ratio has a true 0. Interval, no true 0. Ratio has a true 0. So remember ratio, and it'll help you remember that. So again, the best way on any quiz or anything else for you to remember these 4 is through the examples that I gave. All right, let's talk a little bit about reliability and validity. We are talking about quantitative research, and we are actually measuring instruments and getting measurable values. So how do we know these instruments are reliable? How do we know the Beck depression scale is reliable? Well, there's lots of different ways when they are creating instruments that they come up with the reliability coefficients. That's why most people, for their when they are doing their graduate work, don't try to create an instrument, because it is massive what you have to do to make sure it's reliable and valid. So back to reliability, and you're going to find this all makes common sense. One is test, retest reliability. It's obtained by administering the same test twice, test, retest, when correlating the scores. If I give you the Beck Depression Scale today, and I give it to you tomorrow or later this afternoon, the scores should correlate highly, because that's how we find out if it's reliable. If I give it to you again for the same problem, you should get just about the same score. Then you have parallel form reliability. Now, I want you to think about the ACT. You go in the room, you take the ACT, there's 30 people in there, but there's probably 6 different forms of the ACT. It's administered by identical type test correlating the scores, but they're not identical at the exact same questions. This takes a lot of time to be able to make absolutely sure that this question compares to this question, even though you change the numbers around. But if you take form C today and you take form D tomorrow, your test scores should correlate. Now, internal consistency, again, I told you this all makes common sense. This is by correlating individual items with other, maybe every third item or every fourth item, and you correlate those with every second item. And so you should see that they pretty much are very reliable on their scores. Split half reliability. Guess what? You take the first half of the test, and then you take the second half, and I'm saying test, assessment, survey, whatever, and then you take the second half of the test, and again, the score should highly correlate. Now, there are different types of finding reliability coefficients. One is Coulter-Richardson, and one is Cronbach alpha. Most people use Cronbach alpha because that's with any type of data. Coulter-Richardson is with binary data or data that is categorical. So most people use Cronbach alpha as their alpha coefficient to produce reliability. Inter-rater reliability has to do with qualitative, and so we're not going to talk about that right now. So we talked about reliability. How do we find reliability? Now, remember, reliability has to do with consistency. Every time you hear the word reliability, I want you to think consistency. Now, when we're talking about validity, I want you to think about the instrument or assessment is actually assessing what we want to assess. If we want to assess depression, we certainly don't want the assessment to have questions of self-esteem. In other words, validity is it measuring what you really want to measure. So there are 3 different types of validity: content, construct, and criterion. Content and construct are really very much the same. Content is the extent to which the measurement adequately samples the content domain. So if you look at the assessment, you're adequately sampling what you need to produce a score for whatever domain you're looking for. Construct is the extent to which the test is an accurate measure of a particular construct or variable. So construct is looking at that, whatever that particular construct is, whether it's self-esteem, depression, self-satisfaction with life, whatever it is, you're looking at that construct. Criterion is the extent to which a test is related to some external criterion. And we'll look exactly what that means when we look at the two different types of criterion. Okay, construct. Remember, that is the evidence that you're actually assessing the construct that we want. There are two types of construct validity, and I want you to think about it like this. Convergent validity means that I take an assessment and I give it to you, and I give you the Beck depression scale. I use that a lot. But I'm creating an instrument, and I want to know if it's valid on depression. So I am going to give you the Beck, and then I'm going to give you my new assessment. Now, those two scores, if there is convergent validity, should be highly correlated. And I want you to think about converging. They're the same. They converge together. Now, I also want to prove that it's a very effective assessing depression. So discriminant validity is if I give you my new assessment on depression and you have a score, and then I give you a assessment on self-satisfaction with life, their scores should be very different. If you score high on depression, you should score very low on self-satisfaction with life. That would be discriminant validity. That means they discriminate. They're very different. But again, you can see how that would show validity. Now, criterion. Remember, I told you there were two forms of criterion because we're looking at concurrent validity. When you think about concurrent validity, it yields scores at the time of administration. Okay, a lot of schools do this, and it's a very good idea. They will give third grade achievement tests, but they'll also give an Otis Lennon intelligence test at the exact same time. And so, why would they do that? Because what if a student scores very low on their achievement tests, but they score very high on their Otis Lennon? Well, obviously, they're very smart, but they're not doing well on their achievement tests. You're going to have to go back and look at your who's teaching, what you're teaching, and how you're teaching it. So it's yielding at exactly the same time. Then there's predictive validity. I'm going to go back to the ACT. These are yields score at a later time from administration. You take the ACT, and for years, not as much now, but for years, it indicated your predictive scores in college. If you scored high on the ACT, your GPA was going to be higher in college. It was how they gave academic scholarships. Again, not quite as much now, but used to be very strong. So it is predictive of validity. If that ACT score actually did predict high GPA, there was predictive validity that you could use that in that manner. So those were good examples on criterion validity. Now we're going to talk about descriptive statistics. Descriptive statistics are very important in all studies. And we're going to look at specifics of those, and we're also going to look at a frequency distribution, which is a form of descriptive statistics. It's a summary of the frequency of individual values or ranges. We'll look at an example. Okay, here's a good example of a frequency distribution. All right, so what I'm looking at here are I want to look at years of experience of my employees. I have 10 employees, and we have years of experience all the way from 1 year to 15 years. Now, they divided these years of experience into intervals of 3, but they could have gone from 1 to 15 straight up in the table and not divided. It makes the table shorter and I think more effective since they did it in intervals of 3. But then you're going to find the frequency. So we know there's 10 individuals, 10 employees, but we only have one that has 14 years of experience. So we put the 1 there in frequency. Now we have no one that has experience 10 through 12. We have 1 that's been there, let's say 7 years. We have 5 that have been there 4 to 6 years. We have 3 that have been there 1 to 3 years. So we've put the frequency down, and it's very important for you to add that up and put N. So N equals 10. Now, how are you going to find percentage and cumulative percentage? Now, some people can do this in their head and do it very quickly. I prefer to use a little short equation, which helps me figure out both of these. All right, I want you to think about F, frequency, over N times 100 is the percentage. So F, frequency would be 1 in that particular column, over N, which would be 10. 1 over 10 times 100 is 0.10 or 10%. And that's how you find the percentage. Now, cumulative percentage is a little bit different. What you do with cumulative percentage, you say frequency plus all frequencies below over N times 100. So in that first level, where we have one person with years of experience, 13 to 15, then we would put the frequencies, that frequency and all below. So there are 10 total. So we would put 10 over 10 times 100. The cumulative percentage would be 100%. Again, not difficult, but it's easier for me to use those 2 little formulas to create that. Now, as we go down, we have 10 to 12 years of experience. We have no one there. So the percentage, of course, would be 0, and the cumulative percentage would be, what did I say? That frequency and everything below. So it would be 9, you don't count the one above, 9 over 10 times 100, and that would be 90%. And you continue going down and finding until you get to the total percentage of 100%, and you get a declining percentage on the cumulative percentage. You can do this with any group of numbers.